Welcome to another enterprise session from the University of Bristol. My name is Professor Michele Barbour, and today I am delighted to be joined by Professor Martin Kuball and Dr. Katie Hore. Katie, Martin, it's lovely to see you. Thank you very much for joining us. So I'm really looking forward to finding out about all the work you do together, particularly the Rewire project. But before we get into the depths of that, perhaps you can both tell me a little bit about your backgrounds and what brought you here to Bristol. And you can go back as far in your history or as recent as you please, as it's entirely up to you. So, Katie, why don't we start with you?
Great, thank you, Michele. So I've been working in the semiconductor industry for I think about 12 years now. My PhD was in something completely different, in hydrogen storage materials. And then I was looking for a job in Bristol and started working for Oxford Instruments Plasma Technology. So I spent about 10 years there working firstly in technical roles in the lab, etching 3-5 materials. And then I moved to a strategy role. And after about 10 years there, I thought, well, what else could I do? How could I use these skills somewhere else? And the job opportunity at Rewire seemed ideal as a way to apply those skills to something that had real world impact.
As we go through, I'd love to find out more about that because you're quite new into the academic environment. So I'd love to understand more about how the compare and contrast has worked with that. And I'm sure you bring a lot of skills from industry into this role that are absolutely crucial. But before we do that, Martin, let's have your backstory.
I'm Martin Kuball. I hold the Royal Academy of Engineering Chair in Emerging Technologies. I work on semiconductor technology since probably about 25 years. I run a research center, about 30, 40 people. We work on power electronics, which you use for net zero. We work on RF electronics, which you use for communications or different other technologies related to this. I lead the Rewire project Katie mentioned earlier, where we're trying to revolutionize how you save energies and make effectively our environment cleaner. And also job creation is an important part. And being an academic, I've been always working with the industry, and that has been very important to me because on the one hand, it's exciting to know industry problems and to help solving them, and directing research in some cases, is more fundamental. Maybe the outcome will be in 20 years. Maybe the next one is in 1 or 2 years. And you train students and postdocs who may work for industry. And before coming to Bristol, probably around 25 years ago, I was working in the US, working on developing blue laser diodes. At the time, the US was actually developing blue laser diodes you find in different systems. You found it in Blu-ray players, which you don't find very much anymore. They're gone, kind of. And before that, I came from Germany. I worked in semiconductors. So in contrast to Katie, I was actually doing semiconductors, doing my PhD. I was working on fundamental physics aspects, how surfaces change, how surfaces react, gallium arsenide surfaces, hydrogen, which is quite far away from industry, but it's a good solid foundation then to work with industry.
Martin, that's really fascinating. I've known you a long time, but actually there's quite a bit in that I didn't know. It strikes me that a lot of researchers go on a journey from doing fundamental research to wanting to apply that in a real world context. But you did it quite some time ago, maybe when that was more unusual, maybe when a lot of researchers were more about just the pure research. So how was that? How was that received by your peers? Were you in an environment where that was the norm, or were you sort of stepping out and doing something adventurous and new when you started working with industry back all those years ago?
Probably more unusual. If I think back when I did even one step further back, when I did my master's degree, which was also working with Volkswagen at that point with optical switches at the University of Kaiserslautern, somewhere in southwestern Germany. Mm. It was in a corner of the campus. Mm-hmm. So far away from everybody else, effectively. Maybe not intentional, but for me it's a bit illustrative. When I work in the US had a bit more advance on that at that moment in time. I was working with, at that point, Cree on their blue laser diodes, and also a little bit with Nichia in Japan, having interaction with at least. In the US, I got a little bit inspired. There's the opportunities to talk to industry, to find out the problems, were much greater at that point than in Germany, but in Europe in general. And when I moved to the UK, still unusual. I like talking to people. You go to meetings, talk to people, understand what their problems are. And you start understanding industry has real problems. A physicist or engineer at the university can help doing. And it's not kind of solving a problem in a month, but finding these compromises where you work with industry, help them immediate problems, but also find solutions for 2-3 years down the line. And this is kind of exciting to really apply exciting physics to exciting engineering problems, also developing each of other. And in hindsight, if I think back, it helps also getting funding for the research. That was not the reason why I did it. It was a curiosity what the industry problems are. But in hindsight, this was really a great idea. I should have thought about that first. But it was the other way around. I was just curious, what are the problems industry has?
But actually, as researchers, I think that's a really useful insight, because I think a lot of us are curiosity driven. And yes, chasing funding is something we need to do. It's our bread and butter. But actually, as a motivation, I think to feel that talking to industry gives you exciting new opportunities from a curiosity point of view is a really helpful kind of narrative. Do you feel that the culture in higher education, and specifically in UK higher education, is more embracing of those sorts of opportunities now? Or do you still feel like that's sort of not the norm?
Increasingly embracing, but you also find some researchers saying, I can't work with industry because they're thinking too short term. Then you need fundamental research also, which has nothing to do with industry. So this is an important part as well of the academic society. And no one should be forced to work with industry.
Absolutely.
But people should see the opportunities. If you find the right person, you need to find the right person in industry. Not every industry person in industry is the right place to work with. I mean, for example, also Rewire. I mean, I met Katie even before actually she joined Bristol from the Rewire. We had discussion Oxford Instruments when you're working Oxford Instrument plasma and technology at that point. And even understanding what are issues of equipment manufacturers for clean rooms. It's exciting. I mean, and students can get the excitement as well. I mean, for example, we go a lot to a conference called CS Mantag, which is in the US, which is probably 80% industry. I try to take a lot of students along to this conference, and it opens their eyes. Yeah. What exciting opportunity. And as academic, okay, it's great to write nice papers, but it's equally great, at least, training young people to grow up, to work in industry, to work in academia, and to see their eyes opening up. Oh, there's really cool technologies evolving from industry, but that doesn't mean they have to work for industry, but they could also work for academia and get the inspiration from current problems.
Katie, you're an example of exactly what I'm talking about, which is someone who's gone from their PhD, they've gone into industry, and now here you are back in a kind of university environment. So talk me through how that's been for you, and in particular, I guess, coming back into to this university, has it been what you expected? Have there been any sort of surprises or enlightening moments?
I more or less knew what to expect. So both my parents were academics. My husband was an academic. So I know how it is to work with industry, and I did quite a lot of work with academics in my previous role. I think some of the things that have surprised me is when I did my PhD, particularly in chemistry, it was seen as unusual to work with industry. You know, it was that slightly strange organic chemistry professor who had a lot of money, but it wasn't really quite seen as such pure science. Whereas now, it really is seen as the way to make impactful science, is to have that industry input from as early as you possibly can. Even, fundamental research is incredibly important, but having a conversation with industry. And a lot of people in industry, they are scientists. They love having these conversations. It's just fun. I very much enjoyed that in my previous role because it allowed you to explore things that you didn't have time to when you're in the lab. If you're preparing samples for a customer, if it doesn't work, you just have to move on and try something else. But if you can do a project with a university and explore why that didn't work, it can lead to solutions for the future. So that interaction is incredibly important from both sides.
Fantastic. And I think that's, again, a really useful observation that it's not industry, academia, we're the same human beings. Quite often we cross those boundaries, so that the joy of having fun in your working life, I think, is not something we always embrace as much as we could. I'm glad to hear fun is something that's formed an important part of your career satisfaction to date. Okay, I've held us off long enough. I need to hear more about the Rewire project. So perhaps you can tell me a little bit, maybe if we start with the why. What are you trying to achieve with Rewire? And then we'll get into the nuts and bolts of the who and the what and the how.
I think the main thing I'd like to, and we'd really like to achieve, is creating technology which actually change people's lives. So we're working on new types of power semiconductor devices, and these are the devices that will go into things like 5 minutes electric car charging. So charging your electric car takes no longer than filling it with petrol. Therefore, it's a practical alternative. Things like electric freight transport and electric public transport in cities, making them nice, clean, healthy places to live, and allowing us to sort of explore the frontiers. So things like space exploration. These are small, light, very reliable devices, ideal for sending into space, and allowing us just to do that fun, exciting science that we all like talking about. And I think, Martin, do you want to talk more about the aims of an IKC?
I think we can, before that, I think just throwing in this nice example of the Heathrow fire at some point in the power station. Sure, I mean, there's a good example how sensitive the grid is, actually, how we need to modernize the grid. And then also that's, I think we can hopefully transform with technology, semiconductor technology we develop. And there are multiple of those examples. I had a discussion with a journalist a few days ago, and he was going actually through failures of the grid. And actually he told me, there are actually way more examples where the grid falls down beyond these high-profile events of Heathrow. And it's an outdated grid. The grid has been around for a long time. Obviously, it costs a lot of money to modernize a grid. It's not going to happen from today to tomorrow. But what we're hoping to develop in Rewire, and that's, Bristol-led with partners in Warwick and Cambridge, to develop the semiconductor technology where you can build, in the end, converters, inverters to help the grid. An example is also more going to be efficient, like semiconductor technology typically in this field is 97%, 98% efficient. Doesn't sound the 2-3% you're losing a lot, but if you convert the power down multiple times from 11 or 30 kilovolts, in which country you have, to the 220 volts, you lose 20-30% of the power, and that's a lot. And if I think even a bit further back, there was this call from UK government to these innovation knowledge centers, which is a scheme they developed even before that, but not in the semiconductor space, said, hold on, there's a huge opportunity we can go for to develop this. And I even remember reading the call in detail, kind of, how can we shape that? What are the best partners to work with? And then we just got it off the ground. I was really glad Katie then joining as innovation director, because it's a journey which needs academia and industry background, which Katie brings in. I work with industry, but it's still a different perspective working for industry for a long period of time. And that's beautiful synergy, to have fun, to change people's life, to make energy costs cheaper, to make grid more reliable. And EV chargers is a good example. But then also make the awareness to UK government, it is important to invest into these technology areas. The UK is competing internationally against other countries, and there's a huge market opportunity. Power electronics, which is the technology we're working on, is an 18 billion market for the UK. And that's a lot of money and a lot of jobs.
So you can look at this at so many different scales, can't you? There's the huge economic opportunity and advantage to be gained here. And as you say, it is a competitive space. There's the modernisation of the grid, which is something that a lot of people on the street wouldn't care about until it goes wrong. And then when it goes wrong, it's the most important thing. The Heathrow fire is a great example, but there are many others. And you say that the ones that hit the headlines are a very small proportion of the ones that happen. But then there's the really relatable charging my electric car in the same time it would take to fill a petrol car up with petrol, the really kind of every day, everybody can understand sort of opportunities. So there's a lot of different length scales, I guess, that I would look at this. Tell me a little bit more about the concept of an innovation knowledge centre, because that's something that a lot of people wouldn't be familiar with. So what's the kind of underlying premise? And then we'll talk about how you're applying it specifically in power electronics.
If you look at technologies work in technology readiness level, TRLs, and if it's 1 to 10 and very low is nothing really useful as fundamental research, and 10 is production side. Most funding in the UK from government or different organization is in the lower tier levels. Then there's industry funding from government, which is in the mid-range tier level. But what the Innovation Knowledge Centre are trying to do, bridge more or less the broadest possible range of tier levels, so that we do fundamental research, we translate the semiconductor technology we develop into devices, use those devices to build products, which we then also commercialize with partners. So we have about 35 industrial partners we work with, which we then also use for commercialization and helping solving their problems. And bridging this huge range is developing new things, but then also commercializing. And that is very unique.
And it strikes me that you would have to have, you've already mentioned it, but have to have a very long view if you're going to do that, to be able to be working on and sort of conceiving of the fundamental research, the very low TRLs, but having this anticipation of where it could go, where it could leave, and having the conversations that mean that at least your fundamental research, while it is still fundamental, is informed by where it could ultimately lead. Is that true?
It does take a long time to go from a fundamental idea to creating even just one sort of hero product, essentially. In semiconductors, you tend to have, we've created this brilliant chip. We made 300 of them, one of them worked. And that's brilliant to say this technology could work, but then there is a lot more that has to go into, meaning you can create thousands of those and 90% of them work brilliantly, and you can test them quickly, identify the ones that failed and chuck them out. I mean, that can take, 10, 15 years longer, potentially. And so you do have to have a long view. But having done some of the work on what you think is coming, what the applications are, talking to industry, because you might have an idea that it will be fabulous for the grid, and that's true, but then someone from a car manufacturer can come along and say, actually, that would work great for our charger. So it's getting those different applications together so you know what you're working towards.
Yeah, so the fundamental research is still with the applied research in mind, even though it is fundamental at the outset.
Well, Michele, keep in mind, not everything goes from the fundamental research to the some of it get weeded out, but also the other way. We start not at zero in cases, and company has a certain problem. We can use something we've developed over the last 10 years already and can feed in already now. It has a whole ecosystem around. I've been working for 25 years in that field. So we've done a lot of stuff in power electronics, semiconductor power electronics, but we also work in compound RF microwave electronics are used for communication. Again, there's a cross-fertilization. We had some neat paper out where we developed components for 6G. We have a nice news article on effectively emulating traveling virtually, also diagnostics via NHS or health systems where you don't need to see a doctor. Huge opportunities. That's a technology we developed with an industrial partner. It's not part of Rewire because it's microwave electronics. But again, it may take another 5 or 10 years to actually being a usable product, which, in addition to what Katie mentioned, needs to be at the right price.
Of course, yeah.
Because people need to buy it. Mm-hmm. And Rewire is nested in a whole range of other activities happening.
You've clearly worked with industry partners for many years, Martin. Katie, you have been the industry partner and are now sort of really supporting and generating a lot of new partnerships. I think a lot of researchers would be familiar at least with the concept of having a partnership relationship with industry, even if they haven't done it themselves. But Rewire has 35 partners, you said. So tell me a little bit about that, what the nature of those partners. Some of these partners are in competition with each other in the marketplace. So how can you partner with multiple at once? How does that actually work in practice?
You need to find, we have open events where different parties, we work with material suppliers, we work with people who make clean room equipment, we work with suppliers who make devices, we work with suppliers who are end users. Yes, they're competition. And we have open events and people talk with and reason. Mm-hmm. But then we have also one-to-one interactions, which are then shielded with non-disclosure agreements from other partners. Mm-hmm. So you need to find that balance of both.
Yeah, so there's, to some extent, those initial discussions, there are projects you can come up with which are pre-competitive. So something which is a significant number of years out, perhaps a company isn't working on in their R&D program, but they're interested in it, they want to know what's going on. And companies do tend to be a little more open with each other on those problems because they are, there are long-term problems and they're things that need solving before they can bring that to their in-house R&D. Companies do tend to be quite open about that. Mm. And then, as Martin says, you have individual discussions on individual problems, and companies, I think, are on the whole quite, so long as you have the reassurance and the trust there, they're comfortable of working with a university or a company, because a company will be working with multiple competitors. Yeah. Oxford Instruments supplies huge parts of the semiconductor industry, and our customers, came to us and were trusting that we wouldn't pass that on. And exactly the same way you can work with the university. So long as you have that relationship established, they're happy to work with you on their specific competitive problems.
Michele, if you take that in a different angle, you said we work with companies which are compete, but we work also with companies through the whole supply chain. Yeah. So it's the other angle, and we have the lateral angle of competing companies and the vertical angle of companies which feed into each other. For example, a materials company will provide materials to a compound semiconductor device manufacturer. And you have also these interactions, and hopefully what we're doing, and I think we're seeing this already, that the interaction we're creating with Rewire, getting these partners together, makes also these connections so that we have, is a field we're growing a crop on effectively.
Yeah. There's a convening angle then, it sounds like, for the university partners. And I think you said there are 3 university partners in Rewire, is that right? Cambridge, Warwick and Bristol. But partly what you're doing is actually bringing these companies to meet each other and to maybe understand one another's position a little bit better. So it's an important sort of, and again, an ecosystem building role as well as the direct researchers working on problems that are well informed by industry needs, right?
That is correct. I mean, we ran an event, for example, last year. We had about 100 people in the engine shed, and the excitement, people talking, exchanging ideas and seeing what they can actually develop and have access to was great. We're going to run one in November again this year. And we had UK government as well. We had local government there as well, because for them it's important to see the growth of economy and jobs at the same point. It's partnership, working together, universities with industry, but also with government.
Absolutely. It's that triple helix, isn't it? And are these companies that you work with primarily sort of national, international? Do you also work with smaller companies in this project?
Both.
Yeah.
So we are UK focused because that's where our funding comes from, but we work with global companies based elsewhere, and small startups based in the UK, particularly around Bristol. It's always good to work with startups because they have a lot of ideas and a lot of input to put into that.
A lot of agility, but
yes,
having worked in the startup environment myself, not always that sort of long-term security. So this kind of interaction, I think, can probably help build their pipelines as well.
Yes, exactly. And then you have the longer term relationships with established companies, so you can really get that trust going to build, they can bring a problem to the University of Bristol and we will help fix it. We do have the expertise to really contribute to what happens next. And therefore they'll probably come to us with an earlier problem next time, or a more difficult problem, or just an idea. And so, large companies, you can form those really productive relationships.
Also keep in mind, Michele, so the local companies, international companies. Semiconductor technology is international. You cannot prevent this. Also for the country of the size of the UK, you have to go outside. So we have interaction with companies, some of it with the UK office, but some don't actually even have a strong UK office, have more a sales office who work with their main R&D center in a different country. But still, for example, best known as company is TSMC in Taiwan, which manufactures a lot of products for people. If things are designed in the UK, and the IP is whole held in the UK, wherever it's manufactured, in some cases you like to do it in the UK, but it's not critically important. Whoever is best suited to manufacture, we own the IP as UK, or certain UK entities. We make the product. The further you go up in the product chain, the more profit margin you typically have. So if you make the material, you have the smallest profit margin. If you sell a full product like a phone or communication system or a charging station, that's typically, not always, typically you have the largest margin.
Fascinating stuff. Brilliant. So, okay, I feel like I'm getting a good understanding of your roles and how you work together. Katie, tell me a little bit more about your kind of day-to-day role with Rewire. What are the sort of things that what you need to prioritise, the kind of problems you need to unpick?
Yeah. So there's a lot about forming those relationships and just spending time talking to people, setting up calls, talking about Rewire, getting the right academics in the room. And then there's quite a lot about understanding the industry. So where is it going more broadly? Yeah. Where can Rewire make a real contribution? And where are we going to make the most impact? And who do we have to bring in so we're able to do that? And then there's a sort of longer term strategy piece, which comes in with like, what products do we need to create so we can fill that gap, and what products industry and other academics actually going to want to come in and use within Rewire. I also spend quite a lot of time at events, so talking, telling people about what we do, just talking about the science, which is the fun bit, to be honest.
For example, we both had a discussion over coffee. How can we make industry known and not academia known what services we can provide to them? So how can we, for example, detail that's how they access clean rooms for prototyping, for testing facilities, and so forth. And these are things we also then work together, how to actually develop these gateways from external parties into actually where they can actually help develop a product. Like a clean room is expensive. As small companies, you wouldn't have one yourself, but it's cheaper to access a clean room.
But that's interesting. I've done a number of these interviews of late, and actually that sort of service aspect of what you do, which I had not appreciated was a part of the Rewire sort of undertaking, is something that a lot of people are grappling with. You have a service that's specialist that small companies won't have their own. They need to access on a need basis, or large companies too. And that sort of that gateway, that marketing challenge is not insignificant, actually. So I'm going to be probably sending a couple of people to your door to find out how you're doing it. But you're ahead of some, I think.
How do you make it easy for people to find something? For example,
to know it exists and then to access it.
It's hard. Yeah. It's actually hard because I sometimes Google something up. I like to have this tool and not necessarily finding it easy.
No, absolutely. It's how we make it really easy to find, because people don't have hours to search for these things. They need quick answers. And I think it's not a trivial undertaking, but it is something that's more and more something we as universities need to grapple with and find solutions to, because we have some really exciting kit, not just us, lots of institutions, and we need to be able to be making that available to the people that need and want to use it. So I've got a much better understanding now of your roles. Who else is part of this project within the institution? So what do you get sort of postgraduates involved in some of these conversations, or postdocs to sort of inform them about the wider context of their research? Who else is part of this?
I mean, we have Alex Oliver, who is business development manager. He helps with the business engagement. We have Abby, who's center manager, who does a lot of the logistics. We have Lunto, who does a lot of the IP side and contract side, and from the administrative side, Simon. So we have that administrative team in addition to us supporting here. And then we have lots of postgraduate students and postdocs, and naturally other academics are involved in it.
And do your postgrads and your sort of early career researchers, how do they respond to this? Have they come to you, Martin, because they know you work with industry in this way and that was what attracted them to work with you? Or have they come to this from the point of view of research and this is opening their eyes to applying their research in a different context? Like, what effect does that have on them?
The group I run is pretty well known international. So we get a lot of people just approaching, can we work for you? And then they say, oh, you can work with industry. And that industry angle, they typically find very exciting. And even those who come here not aware of it, this is really cool to work with industry. So then you open their eyes. But it's a track record you build. Yeah. It's naturally hard to find good people, students and postdocs, PhD students and postdocs at the same time. But having a good reputation and knowing people across the planet helps.
Yeah. It builds that. You say that reputation, and then you're attracting amazing researchers, but maybe also those who are open to working with industry from the beginning, rather than you having to make the case that that's something that's attractive.
And the network. When Katie knows people, other people knows people. Is people know people who know people.
Yeah.
And it's science and engineering is not just a machine. For sure. There are people around. I mean, there are also some particular researchers who don't like that particular aspects, but I think that's the strength of the Rewire, I think, in general, that we have people working together, we have a lot of events, we have a lot of interactions. I think we're probably around 2, 3, 4 meetings with a good number per week, just getting brains together to brainstorm, how can we do better? We had a strategy planning session yesterday with a few core academics. I think we're doing good stuff, how we're doing it, but there's always room to improve. How can we actually bring it even one notch higher?
So on that basis, I guess, then what's ahead for Rewire? You've given us some flavour of some of the really long-term goals and some of the nature of the partners you're working with and how you work with them. What are these sort of priorities over the next 12 months, and where is it going after that?
We've had our first year, so we've had our first 12 months. I think it's considering how that went and then setting out what we want to do next, which for me is finding those products and finding the way to market them in a way that's efficient. Because we have a team, but it's a relatively small team. There is a lot we need to do. So we need to define the products very closely and then market them to industry, and then make sure we've done that in the way that industry want us to. It's the easiest way for them to contact us, because there's no point making it overly complicated, which is something the university can be quite good at times.
Yeah, absolutely we can. And however much a lot of us want to simplify it, It's not always simple to simplify.
No,
Yeah.
and Luntu, who's done a lot of work with contracts, has been absolutely amazing with that, with challenging things. Is this necessary? Can we, move on and do it in a slightly different way? And that's been very good for Rewire, and hopefully has set up a good sort of a good scheme or a good template for the next organisation within the university who wants to come along and do something similar. And then sort of for beyond 12 months, so we're funded for 5 years, so we're already thinking about what are we going to do at the end of there? How do we demonstrate that potentially get more government funding? And how do we demonstrate that we have or we will have enough income coming in to create something that's more self-sustaining? Yes. So we don't need continual sort of funding body input just to run Rewire.
And also what you see kind of in interaction with companies, where you see that initially we had meetings with companies explaining what we aim to do. Mm-hmm. Those conversations, particularly with new companies we don't know, those conversations transfer into what do we do specific now. So in a year's time, I would expect with various companies, like this afternoon we're going out to a specific company to define this is what we're going to do in a year's time, deliver in a year's time for your certain application. I can't say who we're talking to.
No, for sure. But you've moved from the sort of, I don't want to say sales.
To actually making something to define.
And to delivery.
Exactly.
Really exciting, yeah. So over that 5-year arc, and absolutely respecting and applauding that wish to make it a sort of self-sustaining entity, what was success like is such a cliched question, but what would you be really satisfied if it had happened at that sort of 5-year mark?
I think 2 things for me. It is demonstrating that we can be self-sustaining so we can continue with the impact. But also it's just having a product out there, something which you can point to and say Rewire contributed to your phone, your charger, making the national grid more secure. I think that's the way you engage people who perhaps don't necessarily want to come in on the science side, but they can definitely get on board with it's making my life slightly more reliable or more fun.
I mean, equally, you can add to this, if you have effectively nice sales pitch stories, we created this, for example, product, and a young school kid gets excited about it, they might want to do engineering and find it or science and find it. The greatest challenge of industry is people, not finding enough good people. I mean, various companies you work with say, do you know people we could hire? And that's quite common. And if young school kids or students, all different ages, or at a later stage transfer over to go in that particular field, that's also another success, I see.
So it's growing that pipeline of sort of bright and curious people, come back to the sort of curiosity-driven aspects, or the sort of, this phone works better than a previous phone, or now I don't have to charge my car overnight. Why is that? Aha, I find where that is, and I want to sort of get involved personally. That's a dimension for you.
UK-made product, or UK-led product, UK LPSC, and effectively aligned with the UK government's growth strategy that we grow the UK. And I think we can make actually real impact for this. And I mean, also bringing up small startup companies, as Katie mentioned. Or if I have my own startup companies, I'm up solutions where I see the different angles and the challenges, but seeing startup companies grow into something bigger would be absolutely exciting.
And for a startup to have a place at this table that you've created through Rewire, which is so exciting, it's having access to those conversations to understand how your product as a startup might be used in the next stage in the supply chain, or might benefit from innovations in the supply chain before you. That's really valuable. And as a startup, it's not always easy to access those conversations. It's not always easy to get to the right person in the company, never mind the company itself. So again, I think I'm really finding a strong theme of that convening power of the universities in this dimension. What about the relationship with the other universities? Is there do you each bring specific expertise, the 3 universities, or is it more that you're all experts in the same area and therefore there's a critical mass sort of dimension?
So when we developed this program, we looked at who are the best complementary universities fitting together. I mean, it's also, it would be great to involve 20 universities. It doesn't make sense logistically. It's a nightmare. Traditionally, IKCs were 1 university with a few exceptions, previous ones, and we settled on 3. Warwick has specific expertise in silicon carbide, which, for example, we have some, but not to the extent Warwick has. Cambridge has tremendous materials characterization capability and certain growth capabilities, and others as well. So who is best complementary. Naturally, there need to be enough overlap for people to work together, but not 100% overlap. That's not going to work.
So before we get into the details, let's not make assumptions about the expertise of our audience or indeed of your interviewer. Tell me a little about these semiconductor technologies that you're working with. And there are lots of different kinds of semiconductors. So why are you working with the ones you're working with?
So semiconductors are any materials that are used to make devices which handle electricity or light. And they're things that we use in our everyday lives. We're totally reliant on them. If you start counting them up at the beginning of your day, you very quickly get into large numbers and have to forget about it. So 80% of the semiconductor devices that we use today are made of silicon, which is great. It's a material that's really readily available. We're very good at using it and manipulating it. But there's certain applications where we're getting to the limits of what silicon can use. And so we're looking for other materials. And these are often things called compound semiconductors. So just materials that are made of two or more elements. Particularly in Rewire, we're looking at applications in power semiconductors. So these are devices which deal with very, very high amounts, very large voltages of electricity. And silicon, to make a device which deals with, kilovolts of electricity in silicon, you need very large devices. And for the national grid, transformers can be the size of a container.
Wow, okay.
And this is getting expensive and not particularly sustainable. And we're having to deal with higher and higher voltages, particularly coming from things like wind farms and solar farms. And so we're looking for these other materials which can deal with these devices so that container-sized transformer in silicon can become suitcase-sized if you make it out of silicon carbide. And so some of these materials like silicon carbide and gallium nitride are really, really good for these applications because of their internal structures, because of their electronic structures. They're capable of dealing with these higher voltages before the devices start to break.
And by making them smaller, that improves a lot of things. I mean, it's obviously more practical, it's cheaper to make, there's a better sustainability sort of angle to that.
So they're small, so they're potentially cheaper to make, not yet, but they will get to that point. They're capable of working at high temperatures, so you don't need so much cooling, and you do have to develop other ways to package them, to house them. But once you've done that, because they're capable of working at high temperatures, they can be very reliable, and they can also be more energy efficient. So you lose less energy in your device. So for net zero, that's brilliant because then you have to create less energy in the first place.
I mean, also adding to this, as Katie said, we use semiconductors. The problem and the good thing at the same time, semiconductors, they're all aligning everything. So you don't even know you're using semiconductors. No. People don't even know this. Like in your phone, you will have a lot of silicon in there. You have some gallium arsenide in there for the radio RF components. For your chargers, if you have a small, tiny laptop charger, this will have a gallium nitride component in there. If you have or see an electric car, that will typically either have silicon or silicon carbide in there. So silicon, 80% of the market. Gallium nitride, silicon carbide is in the market, and Rewire, we're trying to actually improve their profile and performance even more. We develop new materials, gallium oxide, aluminum nitride, so they're next generation materials which will be able to handle higher voltages, for example, for grid applications. And this class of compound semiconductors, the UK is actually very strong. And it's smaller market size than silicon, but we can make a real impact. 5-minute chargers, grid applications. And if you look at UK government, they invest in combat consciously, and the team of Rewire, Bristol, Warwick and Cambridge has a very strong track record in these semiconductors to make innovation to deliver. In the South Wales area, there's a strong semiconductor activity in this field, and there's numerous companies around. We're also engaging with them because it's a commercialization route. So we can actually develop all the things which people don't know they exist and they can use, and save energy, make life easier, make life safer, make healthcare better. And that's exciting from our side, that we can make an impact on people's lives rather than just writing a paper which ends up in a journal. It's still an important aspect of writing a paper, disseminating people.
Of course, but they're having that wider impact. Yeah. And so it sounds that within the compound semiconductor space, there's what is in scope for you is both improving and further developing existing known compound semiconductors, but also scoping the ones of the future. So that's sort of Horizon 3. You mentioned gallium oxide, for example. So that's in scope as well.
We have one of the few gallium oxide growth reactors in Europe, and we develop materials, deliver materials within the Rewire, but also to external partners. It's a low-cost technology. We found an exciting way where we can even grow gallium oxide on silicon. My PhD student who came to me last week in the office said, cool, I can handle this. This works. And this would even, we're still working on this. We're thinking on, can we patent certain aspects we've done here? We'll see. And that could give a huge commercialization opportunity, maybe even with a new startup from the university. We'll see how that goes.
That's really exciting. So in the fullness of time, please introduce me to that person so I can interview them next year or the year after. That sounds amazing. So tell me a little bit more about the kind of applications. You've mentioned, for example, rapid charging of electric vehicles. What are some other ways in which some of the semiconductors that you're developing with partners could have an impact on sort of regular people's lives?
If you take the example of grid and charging at the same time. If you charge a vehicle, it takes 40 minutes plus minus or something to charge a vehicle. There's some news announcement from BYD in China which claim to have a 5-minute charger. I think we can still do it better. I don't have an electric car. I would love to have one because it's reach and how long it is actually taking to charge the car. And I think if it takes me 5 minutes or less than 5 minutes, I can drive 1,000 miles. I will have an electric car tomorrow because it's a benefit. It's cost. It will be always more expensive than a fuel vehicle. Subsidize it maybe from government and make it interesting cost or help cost side, but it's a long-term saving and environmentally the right thing to do. And if you look at the grid application, it goes from an 11 or 30 kilovolts down. It's converted out on 4, 5, 6 steps down there. It's not just I have my power line and my 220 volts come out. There's a lot of stuff in between where you waste energy. And people are concerned about building a new power station. Why not having less power station and waste less energy?
Just conserve more of it.
Absolutely.
And you mentioned briefly potential healthcare applications. Is there anything more that you can tell us about that?
From the healthcare side, power and how to power the components is an important aspect to it, kind of that you have safe power in the hospital. If power goes outside, you don't want to lose the power in the hospital and have issues on that. But, we have the Rewire where we work on power electronics. Separately in the research group, we work on microwave components, which transmit information. People use 5G, but for 6G, you have to go away from what people use nowadays as semiconductor technology. So we developed some components which can incredibly handle way, way more data.
Okay.
So you could do effectively 3D, whatever diagnostics of people probably on the not that long term ahead, but mid-term ahead, with that high communication rate semiconductor technology we developed recently.
Okay, so that could be done sort of remotely or in different locations as opposed to having to be... Okay, that's...
Or you talk to someone who's on the opposite side of the globe. Old days phone, then Skype, and other approaches now. But think about you have that in 3D. You can wrap your hands around someone and feel someone. That would be different. It still probably doesn't replace the real interaction of people, but it's one step above. We need higher data rates for doing that. And with components we develop in programs outside Rewire, but there's a synergy.
For sure,
still compound semiconductors, a different angle.
Yeah.
The exciting example is that these materials have the potential to be very radiation hard. Okay. So if a device is hit, say, by a neutron or a gamma ray, it can cause damage. And they can still be damaged, but damaged in a less overall destructive way. So they can still continue working. Some devices can even potentially self-heal. So this is really interesting for space applications, but it's also really interesting for future fusion reactors, because the inside of your reactor is going to get very radioactive very quickly. Sure. You can't send people in there. And you need to be able to maintain it regularly to replace all the coating inside the reactor. And so this is done currently by sort of remote play-by-wire robots, but there's still limitations in what that can do. There are delays, you don't get that feedback. So being able to have a lot of your power components in the reactor and have them keep working for a reliable, useful amount of time will allow us to maintain those reactors in a way that's sort of quick and efficient and very safe for the people doing the maintenance.
the potential applications of this are just vast, aren't they, across such a wide range of sectors and applications. It's incredible.
Commissioning of old reactors is
Yeah.
the same aspect. I
Yeah.
mean, it's quite challenging. And with robotics, which uses radiation, hard semiconductor electronics, you can go one step beyond what is possible nowadays.
Phenomenal. A recurring theme when you're talking about all that you're doing and the potential applications is that international dimension. While this is a UK sort of focused and UK-based initiative, project centre, you have lots of international collaborations. So talk me through that a little bit more. How does that work? Does that bring challenges? Does that bring advantages?
I mean, we work international a lot with people in the US, in Europe, in Asia, historically, and also in Rewire. I mean, taking one specific example, we're working with Nagoya University with Amano Sensei, who got Nobel Prize in 2014 for developing blue LEDs, and now there's a lot of also power electronic developments. So we're trying to find ways in tandem how we can actually jointly in a UK-Japan way develop this next generation technology. I mean, they work a lot with automotive industry in Japan. It's huge. I mean, they also have their sites in the UK. So it's a nice tandem arrangement between the UK and Japan, corresponding Taiwan, a lot of semiconductor industry. We work with, we have strategic alliance with a few of those exchange programs, have researchers going forth and back. They learn about the culture, but probably more important or equally important is they develop semiconductor technology jointly together. And this developing trust, long-term trust, which hopefully then results in growth for UK economy and people in general.
And I think that people exchange is so important as well, because, I mean, we do live in a global society. There's no unwinding that and actually having that scientific engineering collaboration. But also, I do think the benefits of experiencing different cultures and being in different places is fundamentally beneficial to all humans.
Universities are melting. I mean, the research group itself, my research group is a large fraction from people from outside the UK.
Yeah.
Obviously people from the UK. And that melting pot of different countries itself is also a positive thing. And then we work with outside parties. And that's a positive learning experience. And interestingly, you see actually technology advancing faster if you have this different cultures, different backgrounds, different genders, different nationality coming together. Each person will have a different angle on solving problem. And I found it very exciting to see what is possible.
Brilliant working in a group where everyone comes from a slightly different background or, a slightly different culture, or they've done a slightly different degree. In semiconductors, a lot of people think it's just electrical engineers, but it is a lot of actual engineers, but there are a lot of physicists. I did chemistry. People are coming in from all these different backgrounds, and they do think about how a material works in a very different way. And it allows you to solve problems. It allows you to kind of look at the whole problem rather than just coming at it from it must be electronics. Whereas I'm coming at it being like, it's a lot of atoms. That looks fun. That sort of aspect.
Power of interdisciplinarity, I guess, isn't
exactly.
It? Wonderful.
The side angle we do once a year, or maybe sometimes twice a year, and it's an International Food Day where each person brings from their own country.
I like that. Yeah.
And that's really fun. I've tried things out. People brought on, this is really good.
That's a definite additional benefit of working in a truly international team. Fantastic. Both of you have had and continue to have such exciting, rewarding careers, and your enthusiasm for it is just evident at all times. You also have careers that a lot of people who are earlier in their career might well aspire to. So I guess what would you be your advice from someone at any stage, really, sort of like school leaving, degree, PhD, and so on, if they were listening to this and thinking, actually, that's where I want to be in 10, 20 years, what would you advise them? Katie, maybe we'll start with you.
I didn't have a particular plan. So I think it's fine to make a plan. It's probably a good idea, especially if you don't know quite what you're doing. I mean, I kind of knew I needed a science job in Bristol. That was my plan at the time. And I went to the interview it was a very short notice interview. So I sort of went, right, I'll go along. It'll be a fun practice. And we had a really great discussion about plasma, basically, about plasma physics and plasma chemistry. And I think the fact that I was really interested in it is what got me the job in the first place. And then from there, I sort of developed a bit of a plan about where I wanted to go in Oxford Instruments. But the things that really helped me progress my career were people gave me opportunities or offered opportunities, and I really took them. If someone gives you a chance, go for it. they are giving it to you because they think you can do it. So you go and grab that chance and take the opportunities that come with it. And that allows you to develop the skills to perhaps plan a little bit more in the future or work out exactly what it is you do want to be doing in a few years' time.
Has that taken you out? It's great to say take opportunities, but has that taken you out of your comfort zone? Or is there a time that someone said, hey, Katie, do you want to do this? And there's part of you that thinks, can I?
Yeah, exactly. I mean, moving from a sort of very lab-based hands-on role to a strategy role was definitely, how do you form a strategy? How do you even come up with something so encompassing when what you have been doing previously has been primarily tactical? And, you're planning projects that are 3 or 4 weeks long, and suddenly it's essentially you've been given a project which is 5 or 10 years long, and you've got to say, I want to be here in 10 years based on this probably slightly sparse evidence for a scientist, and I'm going to get there by doing these actions in the next 3 or 4 years, and then I think we'll be doing this. And you have to sort of continually review that, but it was quite a big leap going from, the customer wants this to where is the business going to be.
I do think that sparsity of data is something that as scientists we can find quite challenging, actually, like particularly at that stage when you're going from the more operational to the strategic. But nevertheless, you obviously did take that opportunity because that's now part of your law. So I guess there's something there about embracing things that are different, but
embracing things
to do it.
That make you feel uncomfortable, and just acknowledging that sometimes you can't go get more evidence. This is what you have. Make a decision based on it as best you can, and that is still a scientific thing to do because we do it in the lab every day on a small scale because you can't get every bit of evidence because you don't have, you don't have a synchrotron to get your exact crystal structure. You've got to go on what you've got from your small X-ray machine. And it's the same, just with a business decision as opposed to what am I doing next tomorrow decision. Maybe
more transferable skills than are apparent at the first glance, actually, because there's still a scientific approach to that. Yeah. And I guess there's also a dimension of you set your plan, you sort of orchestrate your plan, but then you continually review and iterate, and if something isn't going the way you expected, you adjust the plan going forward. So it's that sort of iterative change your views based on new data as it emerges.
Yes, exactly. And give yourself credit for where you got it right, because you might iterate because something else has changed, but actually that decision at the time was the right one to make.
Yeah, and learn from that. And then, Martin, turning to you, I mean, a lot of our audience are researchers at different stages of their career. I do feel that increasingly researchers are seeing the benefit of working with companies for lots and lots and lots of different reasons. So what you're doing is more than ever sort of in the spotlight as where people might want to go. What advice would you give to people much earlier in their research career, maybe at the PhD, RA level? Not just those that work directly with you, because clearly they're already inspired. That's largely probably why they've come to work with you. But researchers in other fields, how is this transferable?
The core aspect is, find a mentor who's experienced. And that mentor doesn't have to be at their own institution, can be somewhere completely else. Someone who you feel you can talk to, get advice, because it's an open field. I remember doing PhD, it's a pathway. You know where you're going to end up. Postdoc is a pathway where at some point when you have, for example, a faculty position, it's an open field. You can go in any direction, and you don't know whether you go left, right, or whichever way you're going. So that's actually, it's great. It's opportunities. But having someone you can bounce ideas off are going in the right direction, because the problem in academia sometimes is, as a PhD student, one gets a lot of feedback.
Yeah.
Supervisor,
and direction.
Hopefully, should at least tell you doing right or wrong, and you should do this and that. The more you go on, you get less feedback, or it's indirect or very time delayed. So having a mentor where you can bounce ideas off is extremely valuable. And be open with that person. I'm struggling with this. Can I do this? Or do you think this is a great idea? Or maybe sometimes teaming up with a mentor or someone else. As a young academic, it's very hard to get funding initially. Once you have the first funding, it's easier. Team with someone up who has experience. And with this, you not only learn how to write a grant to get money and get funding, because in the end, that what drives you. Unless you have research, you need funding to do something. And get that advice. And one of the best advices I got actually from a program monitor in the past, and I didn't get it at that point. he told me, I give you money when you have money. And I thought, I have no money. I really need money. Why don't you give me money? Because people who give you money need to justify to superiors if it goes wrong or if it goes right. So if they know you have funding and you deliver, it's much easier getting funding.
Absolutely.
And just if you work with someone experienced who has that, you have that extra gain. And
they de-risk you, in effect.
Risk you.
Yeah.
Yes, and you learn at the same moment in time and you get good connection. And just talk to people.
Yeah.
Don't try to lock yourself in. And also, the more you go in the career, I remember when I started my research group, I started with 1 student down to 5, and there's always a risk people micromanaging students or something like this. And at some point, you can't micromanage people. I mean, it's not very good to micromanage anyway, but if you micromanage 30 people, you turn insane.
You don't sleep,
You turn insane,
Yeah.
plus you turn the people you micromanage insane.
Yeah.
So you need to find a positive way to engage, motivate people, because your success depends on with whom you work with, your students, your postdoc, other people, colleagues you work with. Motivate them, but don't micromanage them.
Yeah.
Be positive. Don't ignore problems. Address problems, because problems never go away. And there are some very good books people can read about. I'm happy to people contact me, give them some suggestions I find helpful. Like if you have a team and there are 10 people in there and one performs extremely well, you have a job to give. There's a risk to give that particular person the job. And if you do that all constantly, the person will be overloaded. It doesn't help you. So learning how to manage a team effectively, motivate them positively, is something else you can get advice from, either reading books or getting a mentor.
And the reading books one, absolutely. And I would like some of those recommendations for sure, because I love reading a kind of book that helps with those sorts of skills. But the mentorship's an interesting one. And I think it's something that some academics really struggle with, because I think there's a vulnerability dimension to having a mentor, because if you're going to use them properly, you have to be able to say, I don't know, I'm not sure, I think this has failed, I'm worried about, I'm afraid of, I messed this up, I made a wrong call. You know, back to your comments, Katie, about sort of the strategy goals is like, I thought this was going to work and it didn't. So that's something I feel that some academics, we build our careers on our reputation for being good at stuff and knowing stuff and being an expert in a certain area. Being able to say, I'm not sure, or I don't know, or this didn't go right, I think can be quite hard for some people.
It's hard. I mean, vulnerability is hard, and admitting I really messed this up. I don't know this, and some people struggle with this. Universities got better making formal mentorship schemes, in some sense good, but an individual needs to find the right person they're happy to do that with. Someone telling you, talk to this, you're not comfortable, you will never do that.
No.
Find the person, talker, and it can be also a friend or a colleague far away on the opposite side of the globe.
Yeah.
It doesn't have to be one at your institution. Maybe the institution has a formal scheme, but then find something else if you need that. But maybe the person who's your official mentor is the right person. That's even better.
But I guess if you've got a mentorship relationship and it's not working,
find another one.
Find another one. Yeah, absolutely.
And it's a good thing. I mean, people have experience, and people who are successful, most of them, are actually happy sharing this experience.
So it's really clear from everything you're saying that this is a national and an international environment, both your Rewire project and the other aspects of your work. But here we are in Bristol, and you've both come to Bristol from other parts of the country, and you've based yourself here. Is there something particular or special about the local ecosystem here for your work in semiconductors?
I mean, there's a lot of semiconductor technology in Bristol. I mean, Bristol has actually a huge history in semiconductors. I mean, there was a company many, many years ago, Inmos, major company at that point doing mainly silicon. There's still a lot of silicon technology in the Bristol area. A lot of compound semiconductors now as well. They're end users. Take an example, Airbus is here. Great end users. A lot of tech companies north of here. Renishaw, a very good companies who use semiconductors. Oxford Instruments, Blaster Technology in Severn Beach. They're all around Bristol, the area. We're close to the South Wales cluster as well. There's KLA. There is IQE there, and numerous other companies. And I apologize if I missed certain companies. Yeah. There's so much. It's a melting pot of semiconductor compound semiconductor technology around Bristol, and that helps attracting good people. It helps getting the community together. There's crossover to media and aspects which will use semiconductors, and in visualization, 3D. We had some very nice discussion with some people which develop visualization approaches where we can maybe use them for training in semiconductor technologies. It's true melting pot, Bristol.
Brilliant startups here. So with the university and with other, Bath, Exeter, UE, it's a lot of support for startups. So there are startups who are working on the semiconductor devices. So for example, quantum companies and their end user companies. There's an electric aircraft startup, which is just a really exciting thing to think about. Can you replace short haul or very short hop journeys with an electric aircraft? And therefore you're reducing emissions and making it quieter. And aircraft which is good for using in built-up areas, essentially.
And there are also some plans actually building aircraft much longer distance electrification, where they're going to plan to use electronics which cools down to very, very low temperatures, which poses its own challenges. And Bristol has a lot of rich ecosystem in new aerospace development. I mean, think about Concorde was built in Bristol.
For sure. Yeah. It goes back a long way, doesn't it? Yeah. But you said lots of challenges, but like from everything you're saying, you thrive on the challenges. That's what the Rewire project and your wider work is all about, is finding those challenges and those problems and finding ways to unpick and solve them. So challenges are your bread and butter, right?
Absolutely.
Wonderful. Where I like to kind of bring these interviews full circle is my final question, which I'll put to each of you in turn, which is what exciting careers you have had and continue to have. And you've both told me a little bit about sort of where you started out. So if you were to have a window back in time to young Katie, young Martin, and in a sense could have that conversation, what would they think about what you're doing now? Would they be surprised? Would they be pleased? Would they be entirely accepting that's exactly what you planned to do all along? And if you could give them any advice, what would it be? Katie, maybe we'll ask you first.
I think I'd be a little bit surprised I'd moved from a hands-on technical role because I really enjoyed that. And I didn't think I'd reach a point where I wanted to do something else, but I definitely did. There was a point where I thought, right, I like the clean room, but I'd like to get out of it and have a broader, more strategic contribution to a business or an organisation. And so I think that would surprise me a little bit. And I think the advice I'd give myself is just take those opportunities when they come. Give something a go. You will be really surprised what you can achieve when you try.
Wonderful. Thanks.
So the most exciting part I find, why are people successful? Resilience is an important part because people will have failures, but also the opportunities. They just pass by, and whether you notice them or not, that makes the difference in people's life.
So there's the taking the opportunities, but there's even having to have your eyes open to notice those opportunities. And once you've noticing them is part of the challenge, isn't it? And then being brave enough to take that leap and take that step.
Also, as Katie, you said earlier, kind of, in a company structure, you had people approaching you and kind of saying, do you want to take that opportunity? But sometimes they just pass by and no one tells them to.
And having a good mentor helps with that, because they can, even if they're not telling you, they make you more aware of what's going on, I think, around you. And just having a conversation about nothing in particular can actually help pull that out for you as, okay, there's something going on and I can contribute there.
And Martin, what would you say to young Martin, and what would he think of where you are now?
Surprised.
Surprised why? This sounds like you, of all the people I've spoken to, it feels like you were the one that had this plan.
My father was a chemist, so that's a relation what Katie's background training is, and I studied as physicist. Very fundamental physics and stuff. And did I ever think about going to do some very applied stuff? No. I mean, I'd done a little bit during my studies in Germany with optical switches, where it's optical computing, but I was more interested actually understanding the underlying physics. And drifting or moving over to actually the engineering side, and the previous dean told me, or VC of the university told me, you're in the physics department, but you're not really a physicist. I don't know which bracket to put. To be at that border, connecting border between physics and engineering. If I give a talk in the physics department, they tell me, it's great to hear about engineering.
Yeah.
If I talk in the engineering department, they tell me it's great to hear about physics. And it's the same talk. It's a challenge to be at the border between both, but it's an opportunity because not many people can handle that.
To bridge
and
it.
They get there. And that's exciting. And I would have not expected ending up there. I would be proud of myself, and also take the example of Rewire so that it's actually making a real impact on people, hopefully. And I think they're already making some impact on employment and training also people up. They go in industry, go in academia, from all different nationalities around the globe. It's just an exciting field. But would I expect it to end up there? Absolutely not.
And so what advice would you give to yourself?
Look for opportunities.
Yeah.
Have an open mind. Don't be too fixed on your plan. Okay, you should have a plan, yes.
Mm-hmm.
But don't be too fixed on that plan. You have to be there in 20 years. You won't be there in 20 years. Mm-hmm. You'll be somewhere else. Just keep that open mind.
To have a plan, but have a flexible plan.
And be excited.
And be
Have
open
fun.
to opportunities.
Have fun.
Yeah. That's a mantra I can get behind. Have fun. Professor Martin Kuball and Dr. Katie Hore, I'm really, really grateful for your time, your insights, your wisdom, and your advocacy for fun, which I think we can't ever underestimate. Thank you very much indeed.
Thank you, Michele.